Hello everyone. Today we're going to use the TP4056 to safely charge up this small 170 milliamp hour battery. But because the TP's current limit is 1 amp, that's way too high. So we need to limit it somehow. Soldering iron is ready, so we're going to do it. Both wires are about the same length, so it doesn't matter. What we're going to do is after we do the battery, we're going to change the resistor to allow the current limit to be more like 60 milliamps on this 170 milliamp hour battery, because it's ultimately the correct way, as we don't want to hurt this battery. It's a nice battery. I don't know the discharge rate. I will test that, but this video is about how to use the TP to set charge limit, not how to test batteries for discharge rate. So I'm just going to prepare by stripping these wires, which I'm going to very carefully solder onto the battery. I know a lot of you are already going to complain don't solder onto a battery. I agree with you, but I don't have any other option. This battery is very small, as you can see, and even if I had a spot welder, there's no way it's going to deal with those tiny terminals. But I already have another solution. I'll try to keep the battery as cool as possible, because, well, it doesn't need more heat. It's already been heated up before, so I really try to avoid it. So what I decided to do, I got an ice cube. I know that's kind of a very crazy idea. I just set it towards the back of the battery to keep it cool, while I try to solder it as quickly as possible to avoid heating it, because it needs no more heat. Like I said, it's been heated before, because it sustained short circuit due to how dangerously soldered it was before, and, well, it's already been soldered before. Oh, that didn't work. Oh wait, that's not enough solder. Okay, yeah, that should solder this time. Trying to use very light pressure to avoid heat transfer. Battery should be fine. Let's try it again. Let's not give up. Yep, that's the correct polarity. Now, the reason I chose ice instead of something like a large metal block or anything other than ice is because, well, water has a very high heat capacity, way better than metals, most metals. In fact, it can be like 3 times metal's heat capacity. So, it's like a good option. Plus, if the ice cube starts... What? How did the ice cube melt? Oh, wow. Okay, so I have to observe this further now. Wow, the ice cube melted onto the battery. Yeah, well, at least it's not hot at all. Is it moist? Barely, so we're good. Let's give it some time. Okay. Should have had some moments, okay. I know that wasn't so much, but like, I hope you understand what I mean. So now, like, very carefully try to add a little bit more because the wire is extremely loose. And if you're wondering how did it get short-circuited, it was very dangerously soldered. Whoops. Oh. Ooh. That didn't look like a good effect. Well, I mean, the battery itself isn't being a problem in any way. I'm just... okay. Hopefully this works. The ice is starting to melt very quickly because it's getting hot outside, and, well, soldering irons are really hot because they can melt solder, so they need to be pretty hot. Okay, solder joint has been formed successfully. Battery temperature. Okay, what's the battery? Oh yeah, battery's cold. We should be good. I might need another piece of ice. Wait, no, we have a good surface right there. Hopefully that lasts long enough that I can solder the other wire and turn it around. This time it will be easier to turn it around. Oops, sorry. Solder on the wrong one. Okay, let's turn it around like this. Okay. Now, I know that is a pretty crazy idea already, but why didn't I just solder on the TP, you wonder? Because actually, believe it or not, this wire spacing is just right for the TP. Like, it looks like this battery was designed to be soldered right onto the TP, or spot welded. But why did I choose to do this? There's a reason, of course. The reason I chose to do this was because I think it'd be cooler to have like wires coming out, plus that would be way more flexible. And the problem is that the TP is larger than the battery because the battery is so small. I'm trying to do this without shorting the battery. It's already very low on charge even, it doesn't need to be discharged further, otherwise it would risk over discharge. Oh, come on, collect some solder. Okay, I think, nope. Oh, come on. Please don't give another solder sticking problem. Okay, we should be good now. I have to clean the soldering iron every time to try to avoid the solder sticking problem after I figured out that worked so well. But I can't just keep cleaning it mid-video all the time, you know? Oh, come on. This is actually pretty scary, I should say. Ooh, that doesn't look good. We have a short circuit in the making. I'll have to break that off after I solder this wire. A piece of solder stuck to the battery, close to the positive terminal. Now, if you're wondering, oh, come on! Does that have to do with the battery plate chemistry? Or should I just clean the soldering iron? But I hope you could see, because I could not see that. Soldering iron's getting pretty warm. I should not plug it now. Oh yeah, that's a lot better now. I hope it continues to work just fine. It should cool down a bit because it is also very hot. Like, the plastic's getting warm. Oh yeah, and that's melting the solder very quickly. Not sure if that's... Ooh. Battery is... Okay, we should... I think the ice has done its job for now. Hopefully the heat... the coldness of the ice is enough to last... the thermal capacity of the battery along with the temperature it's at is enough to last just enough to finish this soldering without the battery getting hotter than before we even brought it outside. Yeah, that solder's not sticking. Trying to put the solder on the wire first. I don't know why. Well, at least the solder in the battery's going, where did it go? Okay, that's strange. Battery's not popped, okay. That's strange. Where'd the solder go? I mean, from the other. Checking battery. Okay, it's getting pretty. It's a little warm. I might need to get another ice cube, or should I just use a tissue? Couldn't tend to replace this. Yeah. Now my gloves are a little wet. Oop. Well, this tissue should work. And just so you know, I read your comments. if you've ever like thought I didn't notice your comment, as soon as I check my comments, I reply to as many of them as I can. If you have questions or extra information you'd like to share, I'd like to hear it. Just please be respectful in the comments. That's strange. How's it not soldering with my iron, but okay. Did it do it? Did it finally work? Now the reason it short-circuited in the first place was the way it was soldered to the circuit board was so dangerous because of the minor manufacturing defect of the battery. So it can short itself out on the circuit board as if it was designed to one day burn your house down, so you give them a 1-star review. This is the electric lighter battery, like I said, probably. And the problem was one terminal's crooked. That's pretty strange. But that caused so much problem that it did short circuit itself on the circuit board. So I removed it to save it after I figured that does happen. Okay, oh yeah, I wonder what's the battery voltage like. I'll check the voltage right now. 1 moment, please. Okay, so you have the multimeter. 20 volts volt mode. I really hope it didn't drop. It should be around 3.3 volts. Because it cuts off at 3.4 volts and the battery's been sitting. 3.33 volts, that's exactly as we started. So we should be good now. Now let's see the standby current of the TP module. Okay. Oh yeah, we'll have to reverse the we'll have to like twist the wire to reverse it, but no problem. I mean, that's another reason, because I'd have to install the battery upside down or have the TP upside down. So to fix that, I could also just install wires. Now, let's set it to 200 milliamps mode. There's no way the TP is going to draw amps, otherwise it would have already fried my other battery. Okay, so now the whole TP module setup is positive, so then we can look like this. I don't have a circuit. What do I have? Do I even have a circuit now? Apparently no. Either it's so low that I have to go to microamps. Let's try microamps. Because it's saying 0.00 milliamps. Oh yeah, negative. That's a little high. 30 microamps, huh? Looks like 30 microamps are coming out of the battery. Oh, that's drastically increasing. Why? It's like 40 now. You want to see? Get out of the way, hot soldering iron. You can't see that yet. Okay. Oh, come on, just deal with me. Okay, I hope you can see that. You know what, let me focus on that. Let me try. Okay, yeah, the numbers are a bit more obvious now. Okay, now I don't know what's going on, but I think my TP's fine, but doesn't like the multimeter in series. Let me try one more time. Yeah, now it's measuring correct. 3 microamps. Oh wait, was that just because I have the multimeter in reverse polarity? What happens if I reverse polarity the multimeter? I'll just measure. Negative. Huh. So now we are sure that my TPs are not fake. By the way, I did conduct an experiment. Like I mentioned, I test every approximately 48 hours the battery voltage, and it's stabilized at 3.89 volts. After peaking at 3.9, it dropped back down. But it's up till this day, or well, last night I should say, because I checked it last night. It was still 3.89 volts, so I hope it didn't drop from there. I have one little curiosity experiment though. Is the output connected in any way? Let me just see. Curiosity. Maybe do we have a common negative? Nope. Is the positive connected, or is it completely oh yeah. Positive's connected right to the output. So that means that this is actually right here. It's as long as it's not shorting. Okay, it's not shorting. So that means if this came here instead, that would have caused a short circuit. But we're not going to be crazy. We're going to put in the correct spot now. Okay, here's where all the excitement happens, as the battery is now put into the TP protection, but is at risk of shorting out some very absurd way. And now if you're wondering why did I leave it like this right now, when I do get Captain tape, I would install it probably, but I don't have that yet. After all, I am still just a beginner in electrical work. But as soon as I could get that, as soon as I do get it, I would install it. Probably put a small piece of paper or something here, and also cover the terminals, wrap the terminals separately with the Captain tape, then fold them over onto this, and then wrap the whole top over, and then just have the wires coming out from the side, one on either, either have both coming from the same side or one from either side. I'll decide on that later when I do have it. I just get my gloves. Why is the sandpaper stuck to the gloves? Is the soldering iron still hot? Nope. We'll have to reheat it. Okay, put it back in. While it heats up, hopefully it doesn't take too long, because we don't have all day. After all, this is night when I'm filming this. Let me just turn my multimeter off. Now, some of you in my previous video commented that I should install a connector. I actually did in the video. I installed a JST connector in that same video. So when I'm not using the multimeter for some time, I would just unplug this, and the TP is this taped up contraption. Just so you know, there is no short circuit because the whole circuit board here is also taped from the bottom, so there's no way it can short over. And then I just tried my best to solder SMD onto that, even though it was a through hole, because that was blocked up with solder. And I don't have solder wick either. It's pretty obvious that I'm totally a beginner. I mean, I've been soldering for that long. I don't have that much equipment, and nor do I have much experience. Oh, it's heating up. Okay, well that was good. I'm just filing it down a little bit, as I learned that helps avoid the sticking problem. Flux it. Okay, now melt the solder. Yep, I see solder's melting. Now what I like to do is now the wire's pretty long, so hopefully it won't transfer the heat fast enough. Let me just show you. I just put the solder, and then just hold the solder line through till it flows all the way through the hole. Okay, so see how it's now at the back? You just a little bit more so it pours more over the back. Yeah, see how the solder pad is now, can you see that? Oh no, oh sorry, here you go. Now you can, why is my hand so much in the way? Okay, I hope you can see how it's on both sides now. I soldered from the top and I let it flow all the way through to the bottom. Now the negative one. Oh yeah, that flowed very fast. A little bit more exposure time. See, it's not, if you look right now, it's not all the way through on the negative pole. Can you see that right now? Yeah, see how the positive pole is more flowed, so let me just float it. I need a bit more solder though, so it doesn't cause a problem. Oh, I should have flowed through. Oh, not yet. What? Okay, well now. Okay, it's getting there. It's getting there. This is what I actually learned. Professional way to solder. Battery's barely warmed up. Very good. Very good. Now, here's how we're going to remove that resistor Now, I'm probably going to pause to solder on my new resistor network that I built to set the charging current, but what we're going to do, there's this resistor tied between the program pin of the TP and ground. So I'm just going to rip it off like this. So small. Why do they have to use this tiny resistor? I'm like, couldn't you have just used a smaller larger resistor, sorry? It's like, that's absurd. A lot of people have to do this, and this, like, I don't think you'll even see that. One moment, please. Zoom very much in. Now it's stuck to my thumb. Oh, great. Okay. Where's the camera lens? Okay. It's just a black speck right there. So you can see that black speck on my finger? That's the resistor. And like, that's just absurd. Like, do you really have to use such a small resistor? Like, there's plenty of space, in fact. Wait a minute. Let me check. Where is the prog pin? Because maybe I'll just solder right onto the prog pin instead. 200 ohms mode. And, well, we know this is ground right here. Like, I even know that. Now, let me see. Yep, that's still ground, but there's a bit of a resistance across it. Oh, no. Then, prog pin. How's the... Oh, that soldering iron is pretty warm. Oops. Don't worry, it's just like it was blowing its heat at me, despite not having a fan. I mean, that's obvious. Oh yeah, this is getting pretty scary. I wonder what's the voltage on the battery. Let me just check to make sure nothing's happened. What's going on with our voltage? 3.32 volts. It dropped very little bit. Hope we are good. Very careful. Yeah, and there we go. Oops, sorry, wrong volt. I was measuring the wrong thing. So is the TP pin right here connected to the solder pad? Yep, it is. So if I really need it, I could just solder there, but I've done it before, so let me just get the resistor network. Okay, here we go. Now, this I measured to be 13.68 kilo ohm. Now, that's a little low, you'd tell me, because we need around 14 kilo ohm or something, assuming the voltage on the pin is 1 volt, but apparently, like, I did this before with 13 kilo ohm, and it actually got only 67 milliamps instead of the aimed 90, which meant the voltage apparently was pretty low. In fact, we can check it right now. Pretty curious. Okay, 2 volts mode, because there's no way it's higher than that. And we need accuracy between prog. Ooh, what is that? Ew. What's on my multimeter? Ooh, what's happening? Are we getting over? Okay, that's pretty strange. And how's our battery doing? Battery's doing fine. So I'm going to try to solder this resistor network. Like, I'm going to first solder the joints of the resistor network, which is composed of a 10 kilo ohm resistor, two kilo ohm resistors, and a 330 ohm resistor, all connected in series to make a higher resistance. I did that because also my 10 kilo ohm resistors tend to measure a little low. I mean, they do have a tolerance after all. Like, in fact, one of the bands apparently means tolerance. Like the resistor tolerance zone. So I'm just gonna solder the resistor wires together. What's going on? Oops. Now, if you're wondering what battery this is, like if you want to buy this cell for any reason, this is a 170 milliamp hour 601333. Like look up 601333 LiPo battery. It should be around 170 milliamp hours. This one is made by an unusual brand, SPY. I don't know them. So I'm just gonna tell that quickly. I don't know them, so that's that. I don't know where I don't know that, so you don't need to look that up. Plus, you might just find a different battery company selling it. And anyways, so plus the important thing is just the code, really. So we're just gonna. Oh, come on, work with me, resistor wires. Why are resistor wires way harder to cut than regular wire? They're so hard, despite how thin they are. I see, though. It's trying to, like, crush them instead. Oof. Yeah, cut them a little short. Cut one resistor a little short, so we're gonna have to compromise with that. You can see that right there. It's a little short. I'm trying to get the wires really close to each other, like, very, very close, because like so they chose a resistor that's the size of a sand grain. Like, I know it's probably within the rating, because after all it's only a current setting resistor, not a current limiting one, so it doesn't really matter. It's only going to have very small current flowing through it, so power rating isn't important. But like, it's like pretty inconvenient. We all need to do that, because like, what if we have even a 50 milliamp hour battery? I've heard the TP can even do a 20 milliamp hour battery. Of course, that would need a very tiny current to work. So let me see if I can solder this. If this is going to be annoying or frustrating, I'm just going to pause and do this off camera. I really should have soldered this first, not the battery, but at least this is not actually part of currently what's going to happen. I'm going to be very careful. Hopefully it doesn't short circuit over. Turn the solder iron on. Oh, come on, it broke. These are a nightmare to solder, honestly. And like, I don't have SMD resistors, and I don't have reflow soldering. I don't have any of the fancy equipment that they do, the manufacturers of my TP. Like, I think I've even seen modules that have bigger resistor. I don't know if mine was like special with a small resistor, but yeah, that's pretty annoying. Maybe they've just never heard of us people adjusting the TP for our specific battery cell, or maybe they just think we're going to anyways put on a battery that needs more current than that to charge correctly, like 5,000 milliamp hour battery or something, which that would need quite a high current in comparison to this tiny battery. Well, I should say small, not tiny, because there's much smaller, like, I think there's even like 1 milliamp hour battery. Like, I think I've seen that for sale. Yeah, I've seen that for sale. Like, that's really tiny. I don't know how you charge that battery. Even if it is high discharge and thus you charge it with 1C normally, the 1 milliamp is really small. And it's probably not, which would mean you charge it with less than a milliamp. I don't think there's a way to charge it then. But at least I don't have to deal with that. That'd be super annoying. I think at that point it'd just be better to treat it as a disposable battery. That can power literally nothing. I don't see what would actually run with that without actually over discharge or over current the battery. That's pretty extreme battery number. Or battery capacity, very low, too low. But let's just stay with this battery. I'm sorry the video is pretty long, so please, I'll leave in the description if you just want to learn it. Skip to the end of this video when I explain exactly what we did. Like, I'll just briefly recap what we did, so just skip to the end few minutes if you only need to know what I did. But like, you already know like how to implement it, you just need to understand how. Now the formula is you divide the voltage by the charging current you want on the battery. Like, for example, we have 1 volt on the pin, on the probe pin of the TP module. So you multiply 1 volt, divide 1 by the charging current you want for the battery. Oh, oops. Did that bridge over? Nope. I'm just going to start with the other terminal. How did that happen? Okay, well that's pretty convenient. Let me just... I don't have something to remove the solder. But then file it off. Yeah, that was actually, that worked. That's plenty of solder. Great. Let me just very carefully try to... Yeah, that melted just fine. Yay! Okay. Is it sticky? No! We have a solder joint. One moment. Let me just check to make sure though that we have a not bridged over solder joint. Maybe I should have chosen another day to do this, but I started, so I should not quit. Yeah, that is pretty good. That is gonna work. Let me just do one more, then it will be easy soldering after this. Oh, my gloves landed right on the ice cube. Great. And I have wet gloves again. At least, I mean, that's not too much of a problem for me. Okay, there we go. Okay, we have... Let's try very careful. Just a tiny bit of solder. There we go. Let's try to solder. No. Oh, what? Maybe I have to pretend like I learned to do it now. I once used the solder to actually make a wire, and I'm doing that again. Yay, I think we got it. I think we got it. Let me make sure, because it would be very sad if it didn't. Yeah, we got it. A successful connection. No! It just broke again. That's pretty frustrating. Like, we have no other, I have no other way of doing it, and, like, I can't just, like, not do this. I have no other way of actually doing this, or dealing with this battery, as this battery is really small. What was that squeak? I don't understand. The battery is not heated. Okay, battery's not heating up, so it didn't actually short or anything. That was a very weird sizzle. I don't know what happened. So let me just see what's going on with the battery. check the solder joint. I really hope. Okay, we finally have solder joint. So mission accomplished. Now it's just going to be very easy. Just do one last little very easy and quick task. Probably what I'm most experienced in. Soldering wires into a through hole. We're just going to solder the these wires to the TP module's output so that we can actually hook it up. And there we go. Now, I wonder if this battery's high discharge or not. That's another reason I removed it, because I don't know if it's capable or not with dealing such a high current load. Or did they just go with a cheap option and hope that you're not going to use it for too long so you don't damage the battery through overcurrent? Because, I mean, well, they're just simply passing the batteries right, like, without any current limiter or anything, at least what I see, because there's a big MOSFET driven by an IC, apparently a high frequency switching one. So like it probably just switches the transformer, high voltage transformer, on and off very quickly, like extremely high frequencies, like at least like some like very high in the kilohertz, like 20 or something, because of the very high pitched screeching it makes. Okay, here we're getting a solder joint. I really being very careful at the resistor so I don't undo all of my hard work to solder it and then just break it off again. That'd be pretty sad. I'm sure every one of you can agree with that. So you don't want to lose your hard work ever. Like even in general, not just with soldering. Where's the solder going? Okay, we should be good now. And we're done. So I'm just going to bring this inside. And then I'm going to now explain what I did in brief after showing you all the hard work I did. So, one moment, please. Okay, so in brief, what we did is we replaced the resistor and changed it with a value so that we have an appropriate charging current for the battery, and our formula would look like this right here is our formula. Let's say we have 1 volt on the prog pin, which is the current setting pin. Then we want 80 milliamps for this battery, approximately, because, well, it's 170, so 85 would be correct, but let's just say 80 milliamps, so 0.08 amps, times the original resistor, which was supposed to be 1,200 ohms, because, well, I measured it was pretty close to that, and that is a standard value. Most of these values are standard, and like we said, this is the one we want to adjust. This is a charging current. So this is what it's going to be like. This is how you calculate. But make sure you have a standard TP module, like one of these with the USB Type-C here. One of these. Let me focus on that. See, one of these. As this is the one I'm used to. Other models might have slightly different characteristics, but they're usually standard because it's after all based on the TP4056 IC. So I hope you enjoyed. Please rate, share, comment, and subscribe. Thanks for watching.